So today we will learn about some important basics in chemistry. If for example we are having a question which is how many moles of ammonia, NH3 is basically ammonia, will produce if 2 moles of ammonium carbonate will decompose. Okay, the question is asking us that how many moles of ammonia will produce when 2 moles of ammonium carbonate will decompose. First of all, let us think it what is the formula of ammonium carbonate. The formula of ammonium carbonate is NH4 whole 2 CO3. Okay, so now let's look at the equation that when 1 mole of ammonium carbonate NH4 whole 2 CO3 decomposes, what does it form? So it will form ammonia, carbon dioxide and water. And now we will balance the equation. Over here on the left hand side you can see we are having 2 nitrogen atoms, 8 hydrogen atoms, 1 carbon atom and 3 oxygen atoms. And over here we are having 1 nitrogen atom, 5 hydrogen atom, 3 oxygen atom and carbon 1 atom. So the unbalancing is in the atoms of nitrogen and hydrogen. So actually we have to balance nitrogen and hydrogen in the both side of the equation. Left hand side must be equal to the right hand side. So when we add 2 moles over here, like 2NH3, what happens? The carbon is equal to 1, nitrogen 2, hydrogen 8 and oxygen 3. So as you can see over here, the right hand side becomes equal to left hand side. So now note one thing, that when 1 mole of ammonium carbonate NH4 whole 2 CO3 decomposes, it forms 1 mole of carbon dioxide, 2 moles of ammonia and 1 mole of water. So when 1 mole of ammonium carbonate decomposes, it forms 2 moles of ammonia. So the question is that when 2 moles of ammonium carbonate will decompose, at how many moles of ammonia will be yield or will be get? So the answer is 4 moles. How? That when we were decomposing 1 mole of ammonium carbonate, we got 2. But now when we are decomposing 2 moles of ammonium carbonate, so we will multiply this and we will get 4 moles of ammonia. We can also write here 4 moles and the mass in grams, which is 68 grams. So the next question is that how many atoms of nitrogen are present in ammonium carbonate? Like we have to tell the number of nitrogen atoms. So as we know that let's calculate N2, which means there are 2 atoms, and we will multiply the 2 number with the Avogadro's number, which is 6.02 exponential power 23 atoms. So when we will multiply, we get the answer 12.04 exponential power 23 atoms. The formula of calcium hydrogen sulfate is Ca whole bracket HSO4 bracket 2. This is the formula of calcium hydrogen sulfate. Okay, the formula of ferrous sulfate is Fe2 bracket SO4 2. So over here you can see that why we have used ferrous, not ferric, because here the oxidation state of iron is +2 and -2. So we actually balance the oxidation state, or you can say basically charge. Okay, now what's the formula of urea? The formula of urea is CO bracket NH2 whole 2. The formula of urea is CONH2 whole 2. So now if we have a question that how many atoms of urea, like how many atoms are present in urea? So simply we'll count the atoms. So when we count the atoms, there are in total 8 atoms. Okay. Then there's another question, which is how many atoms of hydrogen present in urea. Now we have to calculate the atoms of hydrogen present in urea. So as you can see over here, there are 4 atoms, and H2 multiplied by 2, so it will become 4, and we will multiply this by the Avogadro's number, which is 6.02 exponential power 23, and we will get the answer. That will be the total number of hydrogen atoms present in urea. So now let's look at here that if they are asking that how many atoms are there in calcium hydrogen sulfate, and we know the formula of calcium hydrogen sulfate, CaHSO4 whole 2. So this is the formula of calcium hydrogen sulfate, and now we have to find the number of atoms which are present in calcium hydrogen sulfate. So when we will count the atoms, so we will get 13 atoms. Okay. Now let us discuss about the chemical change and the physical change, that what is actually chemical change and what is physical change. A chemical change, a chemical reaction occurs when there is a sharing of electron, like the involvement of electron causes a chemical change. Okay, it can be sharing of electron, like which forms covalent compound, which is quite ahead, and the transfer of electron, which causes ionic compound. So basically, a reaction which involves electron in it is known as chemical reaction, or obviously there will be a change which will be known as chemical change. Okay, now let's talk about the physical change. What happens in physical change? Okay, in chemical change we have looked at the composition will obviously change, the atomic mass will change, a new product will form. Obviously we know that when electron is shared or transferred, a new product is formed. Okay, now what is physical change? Okay, when the color changes, melting point changes, or boiling point changes, or the substance is melted, or the substance is boiled, or the structure changes, the composition changes, that means this is physical change. So now let us look at some of the examples of chemical and physical change. Okay, for example, we are having thawing of milk. So this is a chemical change. How? Because anaerobic respiration take place in the milk. Obviously, lactic acid and the carbon dioxide produced, and these obviously the chemicals are produced. Means there is a transfer of electron or sharing of electrons. So obviously, it is a chemical change. For next example, you are having burning of paper. Obviously, when we burn paper, we use a flame, and obviously the flame reacts with oxygen, which produces heat, and the paper burns, and it converted into ash. So yeah, the burning of paper is a chemical change because of the combustion reaction. Okay, now we have hydrolysis. Hydro means water, and lysis means breakdown. Basically the breakdown of water, or breakdown of substance with the help of water, or you can say decomposition reaction, addition reaction. What are these? These are obviously chemical change, a chemical reaction, because the electron is involved in it. Either it is transferred or either it is shared. Now we have another example, which is lighting of bulb. So this is a physical change, as a new product is not forming over here. We have just passed the electron, and it's blinking, it's giving us light. So obviously it is a physical change, not a chemical change, because not a new product is forming over here. So it's not a chemical change, so obviously it will be a physical change. Now separation of mixture. Like separation of mixture in what sense? That we will separate the components from this mixture. For example, I'm giving you example of water. Like I'm saying you that, okay, take this glass of water and separate out the components that are present in it, some minerals, some metals, ions, whatever it is, its composition is. I just want that I want to separate the mixture. So what you will do? Also, you will not do a chemical change. You will filter out, and you will get this. For example, in a water, I have added some sand. So, and I asked you to remove that sand. So what you will do? You will simply filter that water, and you will get the sand out of the water. So simply it's a physical change, not a chemical change. Why? Because a new product or the involvement of electron is not over here. There's just simply the filtration is over here.